Assalamualaikum to Dr. Nordin and everyone who are watching this video right now. So today I'm going to record a presentation about Law of Thermodynamics. So my matrix number is 208144 and yeah, let's do it. So So the goals of thermodynamics is actually to describe the transfer of energy. And the two main energy transfer are work, which we denote as W, and also heat, which we denote as Q. As shown in figure 1 here, when a system does work, it will lose heat. Conversely, if the work is done on the system, it will gain heat. So the total work and heat gain and loss of the system is represented by the system internal energy, which is U. And this can be expressed mathematically as change of U, which is the internal energy, equals to the Q plus W, heat plus work. And please note that we will decide the positive values when heat or work is added to the system. We will decide them as positive values, and if the heat or work is released by the system, we will denote them as negative values. So if we use Q minus W here, then our work will be the opposite. So instead of so the work done by system will be positive and work done on system will be negative if we use the equation Q minus W. So yeah, next one. So there are actually four factors that affect a system, which are temperature, pressure, volume, and also heat. So the first one is a closed system. So in a closed system, the internal energy of the system can only be affected by work and heat. Only Q and W will affect our system. No other factors can affect the system. For example, temperature, pressure, and volume, it will not affect closed system. So the mathematical expression here is we can put it as change of U internal energy equals to Q plus W. So next. Okay, the open system. In an open system, there are four properties that can affect our system, which I said just now is the volume, temperature, pressure, and heat. So we also have a new concept, which is enthalpy here. So basically, enthalpy is the heat energy that is absorbed or evolved during a chemical reaction. So for the general equation for open system is H, which is enthalpy. We denote as H equals to internal energy U plus PV, pressure times volume. So there are four types of open system processes. The first one is isovolumetric process, or also known as isobaric process. And in this process, volume is kept constant. Normally, the gas is in a rigid container, as you can see here, so that the volume does not move at all. Sorry, does not change at all because it is in a rigid container. And when heat is added to the system, the pressure and temperature increases, whereas when heat is removed, the pressure and temperature will drop. So in isovolumetric process, the system does work. The system does not do any work. So our work done is equals to zero because instead only internal energy is changes in the process. So as we can see in the formula here, work is actually equals to the pressure times with the change of volume. Since there are no change of volume here, so it basically will turn into, we just denote them as zero. So that's why there is no work done in isovolumetric process. So the second process is isobaric process, where the pressure is held constant. So usually the gas can move a piston in this process, which allows the volume to change. So as you can see here, the volume does change, but the pressure is kept constant. So when heat is added into the system, the volume and temperature increases, whereas when the heat is removed, the volume and temperature decreases. So isobaric process can do work because the volume changes. So you can see that the formula for work is equals to force times distance, and we know that pressure is also equals to force divided by area, surface area, and so we can write it as force equals to pressure times area. So now we get work done is equals to pressure times with area times with distance. And the change of distance, distance times with area is also the same as change of volume. So we can conclude that work is equals to pressure times with change of volume. So that's why in isobaric process, the process can do work. So the next one is the third process is isothermal process, where the temperature is kept constant. When heat is added into the system, the volume will expand and the system will do work. In isothermal process, we need to calculate the change of pressure while taking account the volume too. So that's why we have to integrate here. We need to integrate pressure with respect to volume in order to get work done on or by the system. And internal energy also does not change since temperature is the same. So isothermal process, we kept the temperature the same, so there is no um, internal energy changes. So that's why we can write Q is equals to W. Heat is equal to the work done. Next one. So the last process, the final process, is adiabatic process, where there are no heat flow in or out of the system. However, the gas can expand or compress. Heat transfer will be zero. So our Q we can denote as zero, and internal energy can change since temperature in the system can also change. And the system can also do work. So this process can do work because the volume can change. So we can just write the change of W, change of our work, is equals to the change of internal energy. So let's look into the application of first law. So the first one is heat engine, I guess. And when heat engine is considered an open system, heat engines involved with three properties, which are heat, volume, and pressure of a working fluid. So when the gas is heated, it will expand, increasing the volume of the system. However, when the gas is confined, its pressure will increase. The system will usually have a piston at the bottom, so that the pressure exerted by the gas will push the piston downward. In this process, work is being done by the system, and the movement can be harnessed to do work equal to the total force applied to the top at the top of the piston times the distance that the piston moves. So, okay, let's look into the next one. So the second application of the first law is refrigerators and air conditioners. So you can actually, they are both use the same concept of the first law. So we can just group it together. So when gas is compressed, um, so okay, first of all, refrigerators and air conditioners have closed thermodynamic system. So when the gas is compressed, its temperature will increase, and the hot gas can then transfer heat to its surrounding environment. Then the gas is allowed to expand, causing its temperature to drop even colder than before it was compressed. And this is because some of the energy in the gas is already removed during the compression, and the cold gas then absorbs heat around its environment, which causes the temperature of the environment to drop. Hence, the room or fridge becomes colder. That's why our room becomes colder and our fridge also become colder. Yeah, next one. So let's move into the second law of thermodynamics. So the second law of thermodynamics states that the state of entropy of the entire universe will always increase over time. So we can only decrease entropy, but it requires work. For instance, freezing a water. So we need to put energy to make the water colder, to remove the heat from water. However, the entropy in the universe does increase. That means that if we decrease the entropy of water, the entropy of the universe will still be increased. And yeah, so every time we freeze a water, the more distorted the universe will be. So the next one is any spontaneous process increases the disorder of the universe. So the reason why ice melts and hot coffee becomes cold is because of entropy. So this ice melts and hot coffee is actually some of the application of second law of thermodynamics. And enthalpy is often described as a measurement of disorder, and the total entropy can never be decreased. The total entropy in the universe can never be decreased. It will either increase or remain constant in any process. Hence, heat will always be transferred from hotter area to colder area. And entropy is also very different from energy. And entropy is not conserved, but can only increases in the process, unlike energy. So let's look in the application of second law. So the first one is heat engines. So according to the law, heat always flows from a body of a higher temperature to a body of the lower temperature. So actually, this law is applicable to all types of heat engine cycles including the auto, diesel, and etc. for all types of working fluids used in the engines. So this law has led to the progress of present-day vehicles. Another application of this law is refrigerators and heat pumps based on the reversed Carnot cycle. As I said, if you want to move heat from a body at a lower temperature to a body of a higher temperature, then you have to supply external work. In the original Carnot cycle, heat produces work, while in the reversed Carnot cycle, work is provided to transfer heat from lower temperature reservoir to a higher temperature reservoir. So removing heat from the food items in the refrigerator and throwing them away to the higher temperature atmosphere doesn't happen automatically. We need to supply external work by using compressor to make this happen in the refrigerator. Air conditioner and heat pump follow the similar law of thermodynamics. The air conditioner removes heat from the room and maintains it at lower temperature by throwing the absorbed heat into the atmosphere. The heat pump absorbs heat from the atmosphere and supplies it to the room which is which is cooler in winter. So in both the cases above, external work energy in the form of electricity has to be supplied. So the larger the temperature difference, the larger the external work required. So uh, we can also note that actually the most of the second law is actually also applicable to the first law of thermodynamics. So that is all for my presentation videos. Thank you so much for your time. Um, See you guys later and hope you can give me 5 star. Bye.